All of the atom, which is also called the nucleus, contain two subatomic particles. What are the particles found in the nucleus? Okay, the particles found in the nucleus is number one, proton. This proton is positively charged. Okay, now the second subparticles found in the nucleus is called the neutron. The neutron has no charge, it has a neutral charge or zero charge. That will therefore make the nucleus of the atom to be what? Positively charged. Why? Because the neutron has no charge, but the only charged subatomic particles in the nucleus is the proton. So the nucleus is positively charged. Remember the Rutherford model. Now, the electron is made to revolve around the nucleus in a particular spherical orbit. Okay, so the electrons are found outside the nucleus, while the proton and neutron, they are found inside the nucleus. Remember that the mass number of an atom, mass number, is the sum of the numbers of proton plus the number of neutron. That is to say that the mass of an atom is the combination of proton and neutron. So, does the mass of an atom has to do with the electron? No. So the question says that the component of an atom that contribute least to its mass is what? The nucleus is the mass of the atom itself. The nucleus is the mass of the atom. Okay? The neutron is the neutron part of the nucleus? Yes. The electron, again this is proton. So we have nucleus, neutron, we have electron and proton. Which of the following contributes least to its mass? The electron has nothing to do with the mass of the atom. Therefore, the answer to this question is the electron. If you are looking for the mass of an atom, combine the number of proton and neutron together. The mass of an atom is also called the mass of the nucleus. So the answer to this question is C. Question number 4. Millikan's experiment contributes to the development of the atomic theory in the determination of work. Very easy. Please remember, according to the atomic theory, Hour Millikan discovered or measures the charge of electron. Using the oil drop experiment. Hour Millikan measures the charge of the electron using the oil drop experiment. Hour Millikan write it down. Take your biro and your book, write it down. Hour Millikan measures the charge of electron using an oil drop experiment. So, Millikan's experiment contributes to the development of the answer to this question is A. That's the answer to the question. Millikan contributed to the development of the atom by measuring the charge of the electron using the oil drop experiment. That is the answer to that question. Question number 5 says, what is the valence share electrons for an atom whose atomic number is 17? What is the valence share electron for an atom whose atomic number is 17? This question is very, very tricky. Remember, according to Bauer's principle, we were told that electrons are arranged step by step. According to Bauer's principle, electrons are arranged step by step. And the Pascal triangle that is used in the determination of the energy levels of this atom is 1x, 2x, 2p, 3x, 3p, 3d, and then you have 4x, 4p, 4d, 4f. Then you have 5x, 5p, 5d. You have 6x, 6p. Please make sure you have a Pascal triangle. As you can see on the board, this is a triangle. Okay, now if you have this triangle this way, you can arrange this orbital in an horizontal format by following the steps like this. This is number 1, this is number 2, this is number 3, this is number 4, this is number 5, this is number 6, and this is number 7. So if you have it this way, you can arrange these orbitals this way. Let me clean this out of the board so that we have a space for that. Let's clean out the board. Now watch this. Now, if you start here, you have 1x. Okay, the next one is 2x. Okay, the third one is 2p, then 3x. So you have 2p, and then you have 3x. Then the fourth one is 3p, 4x. You have 3p, 4x. After your 3p, 4x, you have 3d, 4p, 5x. So you have 3d, 4p, 5x, and so on and so forth. Now I want you to know that the s orbital can take a maximum of 2 electrons. Take note of that. It can take a maximum of 2 electrons. Your p orbital can take a maximum of 6 electrons. Your d orbital can take a maximum of 10 electrons, and your f orbital can take a maximum of 14 electrons. So according to Hour's principle, he said when filling these orbitals, electron must go into the ones of lower energy before those of higher energy. If I have an atom whose atomic number is 17, if I have an atom whose atomic number is 17, now how do I arrange 17 electrons in these particular energy levels of orbitals? How do I arrange 17? Remember, the s can take a maximum of 2, p can take a maximum of 6. Oh yeah, let's quickly do that. If I write my 1s, first of all, I will take 2 electrons from this 17 and put it here. So it will be 1s2. Okay? Now, if I go to the next orbital, it will be 2s2. If I go to the other, it will be 2p6. So far, I have arranged 10 electrons. I still have 7 left. So I'll go to the next one. It is 3x2. And if I go to the last one, it is 3p5. And this is the electronic configuration for an atom whose atomic number is worth 17. Now, many students will be quick to shade option A. Peradventure, this one is 5. Peradventure, this one is 5. If you shade this, you have failed it. Because the question says that, what is the, take note of this, valence share electrons for an atom whose atomic number is 17. So they are not talking about the atomic number of this atom. They are talking about the electronic configuration for the valence share electrons. And if you have that, you have to be very careful. Remember, if an atom has an atomic number of 17, it becomes 2, 8, 7. So the valence electron there, that means the electron left in the outermost shell is this 7 that is here. So if I pick out 7, where do we have to arrange this 7 electron in Hour's orbital? It means that the 7 electrons are found here in this place. So the valence share electron for an atom having 17 as atomic number will be what? 3s2 and 3p what? 5. So the answer to this question is not A. It is not B. The answer is word C. Okay? Now we are going to take more questions from other topics in chemistry. Okay? In energy changes in chemical reaction and rate of reaction. Now here is question number 6. Okay? From 6 to 10 is a combination of questions on energy changes in chemical reaction and rate of reaction. Now, question number 6 is, which of the following equations shows that a reaction is in equilibrium? Which of the following reaction shows that a reaction is in equilibrium? Remember, there's what we call the spontaneity of a reaction. And then we were told that this symbol, the symbol here is called your what? Your change in gives free energy. For those of you that have not seen this symbol before, when you see this symbol in your exam, it means change in gives free energy. And what is gives free energy? Gives free energy is the energy available for doing work. It is your gives free energy that will determine whether a reaction will be spontaneous or it will be non-spontaneous. It's gives free energy that will determine whether the reaction will occur or it will not occur. It is your gives free energy that will show that the reaction is feasible or not feasible. So that is why your gives free energy is the major determinant of the spontaneity of a chemical reaction. Now again, there's what we call delta H. This one is called enthalpy change. It's called enthalpy change. Another word for it is your heat change. Another word for it is your heat of reaction. So this guy is called enthalpy change, heat change, or heat of reaction. So wherever you see this in your exam, know that they are referring to one particular thing, which is delta H. Okay? Now remember, they have told you before that if your enthalpy change happens to be negative, the reaction is said to be what? Exothermic. An exothermic reaction is one that involves the liberation of heat to the surrounding. Now, if your enthalpy change is positive, the reaction is said to be what? Endothermic. I want you to take note of that. So, for your enthalpy change, it determines whether a reaction is exothermic or endothermic. But your gives free energy determines whether a reaction will be spontaneous or non-spontaneous. Again, we have another symbol here, which is delta X. This one is called change in entropy. What does the word entropy means? Entropy means the amount or degree of disorderliness or randomness of a system. If I write for you, class, if I write this word, solid, liquid, and gases, and then I give you a simple question, which of these three states of matter is most disordered? The answer is what? Gases. Gases are more disordered than liquid, while liquid are more disordered than solid. Remember that the molecules of solid vibrate about a fixed position, but gases move randomly, colliding with themselves and with the walls of the container. So take note that this guy is called entropy change, and what it means is the word, the degree of disorderliness or randomness of a system. Disorderliness or randomness of a system. Please take note of that. Now, your entropy, if I write for you solid, then liquid, and gases, for instance, what do you think is happening to the entropy of this system? The entropy is increasing because the degree of randomness or disorderliness is increasing. Why? Gases are the most disordered state of matter among the three major states of matter. So if I write solid, liquid, and gas, it means that the entropy is what? Increasing. But if I reverse it the other way and I write gas, liquid, and solid, it means that the entropy is what? Reducing. Now, I want you to know that when the entropy increases, it means a positive entropy. And if the entropy reduces, it means a negative entropy. And I'll give you just two illustrations to show whether the entropy of the system is either increasing or reducing. Take a look at this reaction class. If I have calcium oxide, which is a solid, and it reacts with carbon dioxide, which is a gas, and then the end product becomes chalcocite, which is limestone and is a solid. What do you think has happened to the entropy of this system? Since you have gas here, even though you have a mixture of solid and gas, if you have gas here and gas is absent here, it means that it has changed from gas to solid, or it has changed from a mixture of solid and gas to solid. So this side is more disordered than this because this is just solid. So if you move from mixture of solid and gas to solid, it means that the entropy has decreased because gases are more disordered. And if the entropy has decreased, it is called a negative entropy. Now, if I give you another equation where you have, if I reverse it to have CaCO3X to give us calcium oxide solid plus carbon dioxide, which is a gas, what do you think has happened to this entropy? This is solid. From solid to gas, there is an increase in entropy, or we simply say that the entropy is what? Positive, isn't it? So if you move from liquid to gas, it is positive or increased entropy. If you move from gas to liquid, it is negative or decrease in entropy, isn't it? So take note of this important stuff. The one more confusing problem about entropy is when it moves from gas to gas. For instance, if I have nitrogen plus hydrogen to give us ammonia, NH3 gas, this one gas, this one gas, okay? To balance the equation, we have to put 2 here and put 3 here. Class, take a look at this question. This is gas, 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 everything is gas. But what does happen to the entropy? Whenever you find out that the state of matter is the same, that the reaction is homogeneous, because this is called a homogeneous reaction, where the reactant and the product are in the same state of matter, what do? What you have to do is simple. Calculate the number of moles on the left hand side and the number of moles on the right hand side. Let's quickly do that. The number of moles of nitrogen here is 1. So 1 plus this 3 will give us 4 moles. But the number of moles of ammonia here is what? Is 2 moles. So can you please tell me, class, what has happened to the number of moles? The number of moles has changed from 4 to 2. So if there is a decrease in the number of moles, it means that the entropy will reduce. So if the number of moles increase, the entropy will increase. So for this reaction, you will find out that since the number of moles changed from 4 to 2, the entropy has reduced, also called negative entropy. One more confusing problem about entropy, class. I will give you another illustration. If I have hydrogen, which is a gas, and I have iodine vapor, which exists as a gas. Normally, iodine is supposed to be at solid at room temperature, but when iodine is heated, it's sublimed and turned into gas. So a heated iodine can be made to react with hydrogen, and when that happens, it will form hydroiodic acid or hydrogen iodide. Now, if I have this, I will balance the equation this way. This is 2 moles of the acid. Now let us get, if you watch very well, this is a gas, and this one is also a gas. So when you have gas, you now check them by the number of moles. Let us check out for the number of moles in the reactant side. In the reactant side, you have 1 plus 1 to give us 2 moles. In the product side, you still have what? 2 moles. So if you have 2 moles to 2 moles here, wow, it is quite very simple. Because the number of moles remain the same, it means that the entropy is equals to 0. There is neither a decrease nor increase in entropy. So in this particular problem, where the number of moles in both sides is the same, the entropy is 0 or unchanged. Now let us quickly answer this question. The question says, which of the following equations shows that a reaction is in equilibrium. How do you know that a particular reaction is in equilibrium? Very easy. Remember I told you that this guy is called your Gibbs-free energy, and this guy is equals to enthalpy change minus temperature change in what? Entropy. This is the formula for your Gibbs-free energy. Now, I've told you what this and this meant. This T means temperature. The T here signifies your temperature. This is your entropy change. Now, I want you to note this, please. If your Gibbs-free energy is equals to negative, if your Gibbs-free energy is negative, like I told you, this guy determines whether a reaction is spontaneous or not. If your Gibbs-free energy is negative, we will say that the reaction is spontaneous. Please take note of that. Or we say that the reaction is what? Feasible. So whenever your Gibbs-free energy is negative, the reaction is said to be spontaneous. And what will make your Gibbs-free energy negative is when, please take note of this, if this is the formula, how can this guy become negative here by combining these two variables? That is when this will happen when your temperature change in entropy is greater than your enthalpy change. Because if this number is big, is large, and then you are really a big number, small number, you have a negative value, isn't it? Good. Now, if your enthalpy change, this is point number 1. Point number 2, if your change in entropy is equals to positive, the reaction is said to be non-spontaneous. Non-spontaneous. And if this reaction is non-spontaneous, it means that the reaction is non-feasible. Please take note of that. And what will make your reaction to be non-feasible is to reverse this condition, and that is when what? Temperature change in entropy is less than your enthalpy change. Point number 3. Now, if your Gibbs-free energy is equals to, why I am doing all this is because if you see questions related to this particular nature, you'll be able to answer it, okay? If your Gibbs-free energy is 0, the reaction is said to be in equilibrium. And it is in equilibrium, it happens when what? Please take your biro and your paper, make sure you are jotting this down. It means that your temperature entropy is equals to your what? Enthalpy change. So the question says that which of the following equations shows that the reaction is in equilibrium? The reaction is said to be in equilibrium when your Gibbs-free energy is equals to what? 0. So what is the answer to this question? Is it this? No. Listen, look at what I told you. Temperature entropy is equals to enthalpy change, and that does not relate to this. So it is not the answer. Check out for this, please. It is not the answer. If Gibbs-free energy is less than 0, it means your Gibbs-free energy is negative. And if it's negative, it means that the reaction is spontaneous. Okay? Now, if Gibbs is equal to 0, the reaction will be in what? Equilibrium. Check out option D. If your Gibbs-free energy is greater than 0, it means it is positive. And when it is positive, the reaction is non-spontaneous. I hope that this explanation will help you in understanding the effect of your Gibbs-free energy in a chemical reaction. Please let us take question number 7. Question number 7 says that ammonia, a gas, reacts with hydrogen chloride, a gas, to give us ammonium chloride, a solid. The entropy change in the system is what? I just explained this. If a substance moves from gas to solid, what has happened to the entropy of the system? The entropy has reduced. Why? Because it moves from gas to solid. If it had moved from solid to gas, the entropy would have increased. So please take note of that. A reduction in entropy, as it is in this place, means a negative entropy. So the answer is not A. Our answer is B. Question number 8 says the energy change for a reaction. Now, I'm not going to answer this question because I have answered this question in my previous video where I explained the JAM mock questions for 2024. So go back to that video and see the answer to this particular question. Now let us quickly take question number 9. Question number 9 tells us that if you have methane, this guy is called methane. Take note of that. This one is called chlorine. And whenever chlorine or halogen react with a member of the alkane homologous series, okay, the reaction occurring here is a substitution reaction. Remember, among the alkane, and alkyne, alkane, that means the organic compound having ANE, happens to be the least reactive. Alkane can usually undergo substitution reaction, combustion reaction, and cracking. That's the 3 primary reactions that alkanes undergo. Now, alkanes, remember alkanes is arrow attached to hydrogen or CnH2n plus 2. If this is your alkane, okay, the reaction that is exhibited by alkane is 1, substitution. Okay, now please take note of this. Alkane readily undergo substitution reaction. Please take note of that. Alkane readily undergo substitution reaction. So the reaction peculiar to a saturated compound is alkane. Okay, now but that is not the question anyway. The second reaction that alkane undergo is your combustion. Remember, in combustion, the alkane is made to react with oxygen or to burn in the presence of oxygen. When that happens, the 2 compounds that is formed will be what? Carbon 4 oxide and H2O. Now, the last reaction that alkanes usually undergo is your what? Your cracking. Cracking can sometimes be called pyrolysis. Cracking means the breaking down of large organic molecular alkanes into simpler alkane, and hydrogen. So the reaction that alkane usually undergo is 1, 2, 3. But the one that is peculiar to alkane is this one. Take note of that. So alkane readily undergoes substitution reaction. And here is the typical example of a substitution reaction of alkane. The question says that the major factor influencing the reaction is what? The substitution reaction of alkane occurs in the presence of light. Remember, in one of my videos, when I was explaining factors that affect the rate of chemical reaction, I told you that there are 7 factors that affect chemical reaction, while there are 3 factors that affect a reaction in equilibrium. Okay? Among which it is all of these factors that are here. But in the substitution reaction of alkane, the reaction is usually influenced by light. Light is the answer to this question, which is UV rate. Okay, the last question says that catalyst speeds up the rate of chemical reaction by doing what? Remember, we have 2 types of catalysts. Okay, we have organic catalysts. Organic catalysts are called enzymes. And we have inorganic catalysts. What are inorganic catalysts? Inorganic catalysts are catalysts gotten from minerals or from elements. This inorganic catalyst is divided into 2. We have the positive catalyst and the negative catalyst. So what is a catalyst? A catalyst is a substance that alters the rate of chemical reaction but remains chemically and quantitatively unchanged at the end of the reaction. So if a catalyst alters the rate of chemical reaction, a catalyst can either speed it or slow it down. A positive catalyst speeds up the rate of chemical reaction, but a negative catalyst reduces the rate of chemical reaction or reduces the speed of the chemical reaction. Now, for a positive catalyst, the positive catalyst usually increases the rate of chemical reaction by reducing the activation energy or by lowering the activation energy. Okay, so the answer to this question is what? B. In the other way around, a negative catalyst slows down the rate of chemical reaction by increasing the activation energy. Thank you very much. If today is your first time for coming across the H2O Spirit channel, please do well to subscribe and also like our videos. You can share this video with your friends that are preparing for JAM. Thank you very much. I'll see you in my next video.